Time travel through the eyes of Stephen Hawking. To help understand time travel, think of time as physicists do, as the fourth dimension. Everything has a length and time as well as space. As you walk in a straight line, you're traveling in one dimension. Turn to either side and you've added a second dimension. Walk up or down a hill and you've added the third dimension. Although movies portray energy-devouring machines creating a portal through the fourth dimension, the idea of time travel is not as far-fetched as we are led to believe. So are portals to the past or future possible within the laws of nature? You probably know if we think they are or not, considering they already have a popular name: wormholes. In actuality, wormholes are everywhere, throughout space and time. Nothing is truly flat or truly solid. If you look closely enough, you'll find holes and wrinkles in it. The same thing applies to time. Although a pool table may seem flat and smooth, it's full of gaps and holes. Even a smooth pool ball has tiny cracks, wrinkles, and crevices in it. At a scale smaller than molecules and atoms, there are wrinkles in time. This place is called the quantum foam, where wormholes exist. Incredibly small shortcuts through space and time. They constantly form, disappear, and reform. They link two separate places and two different times. These wormholes are 1 billion trillion trillionths of a centimeter across. Some scientists believe that it is possible to capture one and enlarge it enough to fit humans and even spaceships through. The biggest problem with time travel to the past is paradoxes. The most popular paradox is the grandfather paradox. However, Stephen Hawking came up with a simpler example, what he likes to call the mad scientist paradox. A scientist stands in front of a wormhole and assembles a gun determined to create a paradox. The wormhole he has created stretches 1 minute into the past. After assembling the gun, he steps behind the wormhole and sees himself assembling the gun 1 minute ago. He then shoots his earlier self. He is now dead, shot by a gun he has yet to finish assembling. So who killed him? This is a paradox. This kind of time machine violates a fundamental rule that governs the entire universe, that causes happen before effects. Something will always prevent a paradox. The problem in this case is the wormhole. It simply can't exist because of feedback. The screeching noise created by a microphone and a speaker is feedback. Sound enters the microphone, travels to the amplifier, and becomes louder, then comes out of the speakers. But if too much of the sound that came out of the speakers goes back into the microphone, it creates a loop, getting louder and louder. If not stopped, the sound system is destroyed. The same thing would happen with a wormhole, but with radiation. As soon as the wormhole is expanded, natural radiation will enter it and end up in a loop. This feedback would grow until strong enough to destroy the wormhole. Although wormholes do exist, and if it were possible to expand them, it would not last long enough to use as a viable means of time travel. Along with wormholes, any means of time travel into the past is probably impossible because of paradox. Over 100 years ago, Einstein proposed that there were places where time is slower and where time is faster. This is true. Time flows like a river, and there are parts that flow more slowly and parts that flow more quickly. GPS is made up of 31 satellites in orbit of Earth. The satellites' clocks gain 1/3 of a billionth of a second every day. The system must correct itself for this difference, or it would cause GPS systems on Earth to go out by 6 miles every day. The mass of the Earth is what causes this. Matter drags on time, as realized by Einstein. The heavier the object, the more it drags on time. This is what makes time travel to the future possible. At the center of the Milky Way, 26,000 light-years away, is the heaviest object in the galaxy, a supermassive black hole with the mass of 4 million suns. Get too close and not even light can escape, so it's wrapped in a sphere of darkness 15 million miles in diameter. If a theoretical ship could get close enough but keep enough speed to not get sucked in, it would be pulled into orbit. This orbit would be 30 million miles in diameter. From Earth or anywhere else far away, the spacecraft would be observed at each orbit taking 16 minutes. But for the people on board the ship, time would be slowed by half. They would only experience 8 minutes of time per orbit. If the ship was in orbit for 5 years of their time, 10 years would pass on Earth. This time-traveling method doesn't provoke paradoxes and doesn't destroy itself through feedback. But it's incredibly dangerous, 26,000 light-years away, and doesn't take you very far into the future. Our best hope of building a time machine? Speed. There is, however, a cosmic speed limit, 186,000 miles per second, the speed of light. Traveling near the speed of light takes you into the future. Imagine a track around the entire globe, and on it a super-fast train, capable of 99.99% the speed of light. The train accelerates until it approaches the speed of light, around the world 7 times a second. But no matter how much power this train has, the laws of physics forbid it from reaching the speed of light. At 99.99% the speed of light, time slows on board, relative to the rest of the world, but more so than being near the black hole. This happens so that the speed limit is protected, so that if someone on board started running forward, they would not be traveling faster than the speed of light. Time will always slow down just enough to protect the speed limit. If this train departed on January 1st, 2050, and it circled the Earth for 100 years before stopping on January 1st, 2150, time will have slowed so much inside the train that the passengers would only have experienced 1 week. In 1 week, they traveled 100 years into the future. However, building this train would be impossible. We know traveling near the speed of light has these effects on time because of CERN, the world's largest particle accelerator. When sped up to 99.99% the speed of light, particles called pi mesons, who normally disintegrate after 25 billionths of a second, take 30 times longer to disintegrate. So the only possible way to travel this fast is in space. Apollo 10 is the fastest manned vehicle made in history, reaching 25,000 miles per hour. But we would have to travel more than 2,000 times faster to be able to truly travel through time. So our theoretical time-traveling ship would have to be incredibly massive, large enough to have enough fuel to reach just under the speed of light, and to do this, it would have to travel at full power for 6 straight years. The ship would reach the outer planets in only 1 week. It would reach half light speed in 2 years. And at 4 years, it would reach 90% light speed and be passing Alpha Centauri. At the 4-year mark, every hour passed on the ship, 2 hours passes on Earth, similar to being near the black hole. After 6 years of traveling at full power, the ship finally reaches 99.99% light speed. At this point, a single day on board the ship is a whole year on Earth. This time-traveling ship also gives the ability to travel huge distances in only 1 human lifetime. Although this technology is lifetimes away, we can at least take some comfort in knowing that it is possible to truly travel through the 4th dimension. This video is Chuck Norris approved.